Hello, in this unit we're going to look at forces, but unlike the first booklet where we looked at forces, we're going to look at how forces make objects move. Now, just as a little introduction, we're going to look at different types of forces. Probably the most common force that we will look at is gravity. Okay, gravity is caused by Earth, because it has mass, pulling down on things that have mass. So it's the same force that makes apples fall to the ground, and it's the same force that makes you fall to the ground and stay attached to planet Earth. So if you jump up, you get pulled back to the ground. Another word we have for the force due to gravity is weight. So in physics, weight is a force and should be measured in newtons. However, it pulls you down. You don't go through planet Earth because planet Earth is a solid. So there's another force that is also very common that acts upwards where you make contact with the ground, called a reaction force. Okay. Other common forces, we create lots of different devices and forms of transport and things like that. So this is a car. The forwards force created by engines we tend to call thrust. Still a force, still measured in newtons. We also use that if we are dealing with something like a rocket, so it doesn't necessarily have to be side to side. The thrust from the rocket's engines can make it move upwards. Things that move through the air then have a force on them called air resistance or friction. In fact, friction is a very, very common force that acts whenever you have contact between two different surfaces. It's a force that always opposes motion or potential motion. So it always acts in the opposite direction that objects are moving or are trying to move. They're the main forces. The only other one you might come across every so often is if you have a boat. The weight of the boat pulls it down, but it floats. It doesn't kind of sink in the water because the water provides something called upthrust. Okay, so by displacing the water, it produces a force in the boat, and that is called upthrust. So they're the most common forces you're going to see on objects. It's very rare that we have an object that just has one force in it. So for instance, if we look at the rocket just after takeoff, its weight would be acting downwards, but it would have a thrust upwards. If it's already got a speed, it's going to also have some air resistance there as well, or some friction. So most of the things we look at are going to have more than one force in them, and that complicates matters. So what we like to do is we like to make life as simple as possible. So in physics, if we're drawing objects, you might be a great artist, good. You might not be, like me. So instead of drawing things, what we tend to do is just draw a box, and that represents any object. So that could be a person, it could be a car, it could be a rocket, it could be anything at all. It just simplifies things a little bit. And let's say this is a car, and there is 1,000 newtons forwards, but so that's a thrust from its engines, but there's a 600 newton force backwards. To make life easy, what we do is we try and combine all those forces into a single force that would do the same thing as all those forces combined together. And it's really simple. If those two forces were acting on an object, it would be exactly the same as, well, we have 1,000 going forward, 600 going back. What we do is we subtract the backwards force, and that would be equivalent to 400 newtons going forwards. Okay, so if you notice, that force is just the 1,000 forwards minus the 600, which gives us 400, okay, in the direction of the bigger force. We call that force the resultant force. The resultant force is just a single force that represents all of the forces acting on that object. Now, let's see a different situation. Let's say we have, I don't know, an airplane that has two engines that aren't quite producing the same amount of thrust. So one is giving it, let's say, 4,000 newtons, and another one is slightly stronger, given a 5,000 newtons. We have two forces acting forwards. If they're acting in the same direction to work out a resultant force, we just add the two of them together, and it gives us a resultant force of 9,000 newtons. So what we're saying is, rather than making it complicated and having those two forces, we can do the same thing and have a larger force of, single force of 9,000 newtons. And that just makes our life a little bit easier. Now, how this is going to work is you're going to watch these little videos, hopefully. I'm going to number everything in the order that you should do them. Don't worry if you don't quite get some of the stuff towards the end of those videos, because we will make them harder as we go on. But I'll also put a little worksheet in that you will then do those questions, and I will post the answers to those kind of the following week. Okay, so on the worksheet there'll be a little bit of information, and then there'll also be some questions for you to do, and you should be doing those questions this week. Part of that will be you will be given systems of forces like this and be asked to work out the resultant force. Relatively easy, okay, because opposite directions you subtract them, same directions you add them together. How that can be made harder is if you don't know what one of the forces is. So let's say we have an object and we're told that this is 1,000 newtons, and we're told that there's some force, let's just call it friction, acting backwards, but you don't know what it is, but you're told that the resultant force here is 800 newtons, okay, in that direction. And you have to work out what friction is. Now you might be able to look at that and just say, well, it has to be 200, because if friction's 200, then it's going to remove 200 from the 1000 and give you 800, but we can do it by equations, okay? So what we're saying is that the resultant force on that object is going to equal the forwards forces, 1000, minus the backwards force, which we don't have, so let's just call it FR for friction. We're told that the resultant force needs to be 800, so if we put 800 in there, equals 1000 minus friction. Bring the friction over to the other side, or you could say add friction to both sides. I just invented a zero there somewhere, sorry. So the resultant force is 800, not 8000. Equals 1000, subtract the 800 from both sides, and it gives us that friction must be 200. And what I would always do is go back into your question, put in the value, and then see if it makes sense. What would be the resultant force of that? It would be the 800 that we need. Okay, so if you look in the same folder that this video is in, you will see there'll be a little page of notes that you can read after this, and then there'll also be questions. Try those questions. I'll post the answers next week, and then we will post some more kind of content next week as well. Okay.